not as easy as it looks. Oh, we're on. Okay, right. So, part A said, use logarithms to solve the equation. That was quite kind, use logarithms. Now, there's one thing that we need to spot with this before we do anything else, and that's the way that brackets work. And I probably should have said this before we started the video, but this is quite a big deal, that sometimes we forget how brackets work. We get so used to the idea that if you multiply a bracket by a number, then that just means you multiply everything inside the bracket by the number, and you do that. And that's, you first learned that years ago, and that was your first introduction to brackets, so you thought that's how brackets always work. But then you did other things with brackets. And it doesn't just split up like that, does it? Like, if we do a plus b squared, the danger is that we think that that means a squared plus b squared. And it doesn't, does it? You would have a 2ab. Oh, so that's not equal to that. We do the square root of a plus b, and that's not equal to root a plus root b, because otherwise Pythagoras' theorem wouldn't work. And we do logarithms, the log of a plus b, and it's not equal to log a plus log b. And as we start to write some of these things down, we kind of realise that actually this was the exception, rather than what always happens to brackets. Most of the time, you don't just expand the bracket in the normal way that you used to. In core 3, you are going to discover that the sine of a plus b is not equal to the sine of a plus the sine of b. Okay? It's much more complicated than that. So there's a whole load of stuff that doesn't fit in with these rules. Now, the reason I'm saying all of that, I'm going to just get rid of that bit, is that the worst thing you could do here would be to dive straight into this question and say, it says use logarithms, so I'm going to use logarithms. Okay? And that, while not being wrong, doesn't help you. Because it doesn't really get you anywhere, because there's not an awful lot you can do with this first term here. Because you can't expand the bracket. It just doesn't work like that. So what we need to do is, before we take logarithms, we need to start by rearranging the equation, and so that we've got a single term on both sides. So now we can work with it. And we can choose whatever base logarithm that we like, but we're going to use log base 10, because that's the one that our calculator deals with. And if you just write the word log, it's taken to mean log base 10. So this is log 7 to the minus 3 is log 184. You may also have seen, if you just write LG, then that also means log base 10. It's accepted shortening, right? Now, the third rule of logarithms we wrote down means that this power comes down to the front. So it looks like that. Remember, we're trying to find what W is, so we're going to divide both sides by log 7. And then to find W, you would add the 3 to both sides. You would do this on a calculator, of course. I did this earlier and I got 5.68.
Say that 167 is 4.
You could, because your calculator will allow you to work the base. Yeah, Joseph just made the point. I'm still getting used to this, but if you have a Casio FX83 ES or 85 DT Plus or any one of the later Casio models, you have the option at the bottom that will allow you to change the base.
Yeah.
Now, when we first started teaching this, you didn't have that option. And so that means from this point here, if you really want to, you could write that w minus 3, what would it be? Is log base 7 of 184. So w equals 3 plus log base 7, 184. And if you try that on your calculator, does that give you the same answer? So that's okay, it's perfectly acceptable. The person who wrote your exam paper didn't anticipate you doing it that way, because they hadn't switched on to the fact that your calculator would allow you to do that, because it's a fairly new thing. So that's kind of the traditional way of doing it. But you were right to do it that way, you still get all the marks if you work that through. Okay, part B, we just said this was unconnected. And part B says, solve the simultaneous equations. Well, we need to work on these simultaneous equations. We've got log base 10 of x plus log base 10 of y is log base 10 of 3. Let's start with that one. Again, we're going to be really careful about a whole brackets thing that we may be tempted just to kind of rearrange this straight away. But we can't just dive into this. We can't just say that this is 10 to the 3 is x plus y, because that's simply not what it says. We need to get it as a single term on both sides first. So the first of the rules that we wrote down a few moments ago says that if we add these two things, this becomes log base 10 of xy, log base 10 of 3. And now, well actually this is simpler than it looks, isn't it? If log base 10 of that equals log base 10 of that, then the two that's must be the same. Does that make sense? So x, y and 3 must be the same as each other. Because we're doing the same thing to both sides. So if we just not do that thing to both sides, then it's still the same. So that's one of the equations tidied up a little bit. The other equation said log base 10 of 3x plus y was equal to 1. Just kind of it does not check. You'll be alright. You put a table at the door, they don't tell health and safety. Right. What we've got here is log base 10 of 3x plus y is 1, so 10 to the 1 is 3x plus y. Well, there is our second equation. And if I'm solving simultaneous equations, what I really like is to get something that I can substitute in. So I'm actually going to do a tiny rearrangement of that and say y equals 10 minus 3x.
How did you get 3x plus y equals 10?
This is, if you remember this bit that we had here, that says log base a of b is c, tells us a to the c is b.
Right.
So that was 10 to the power of 1
Right.
was equal to the other bit. That works, doesn't it? 10 to the power of 1 is 3x plus y, so it's only doing that bit. Okay, we've got simultaneous equations. Remember the happy days of Core 1, simultaneous equations. And what we can do next with this is we can have a takeaway sandwich from a well-known national chain of sandwich stores. We can sub y. That was the best joke of the afternoon. So, you know, a bit more than a bit left. Right. X times 10 minus 3x is equal to 3. That's substituting the value of y into there. If we multiply this out, then can we get this? And a little bit of final rearranging tells us that 3x squared minus 10x plus 3 is 0. Now, it is amazing in your AS core maths year how many things end up being quadratic equations, isn't it? How much boils down to that? I mean, I didn't do core 1 with you this morning, but loads of core 1 turns out to be a quadratic. We've done 2 questions from this core 2 paper, and we had to find the discriminant in the first one we did. And now we've got a quadratic to solve in this one. It all comes down to quadratics. We need to solve this. Can we factorise it? You hopefully can put that straight into brackets. If you can't, you know that method, have you seen this method that always is great? If you multiply first and last things together to get, what would that be, 9x squared, and then try and think of 2 things that multiply to give 9 and add to give minus 10. Well, that would have to be 9 and 1, wouldn't it? If it was minus 9 and minus 1. So we're going to split up the minus 10 to be minus 9 and minus 1. So that's the same thing we've just written. And then you factorise things 2 terms at a time. So we just focus in on the first 2 terms. And there's a common factor there of 3x. So we're going to take out our common factor of 3x times x minus 3. And if we focus in on the second 2 terms, there's not really a common factor there at all, but there is, we could take minus 1 out to the common factor and still have x minus 3. And what happens there, the great thing that happens there, is if you've done this right, these 2 brackets will always be the same. So we've got, we'll go back to the normal pen now, we've got x minus 3 times 3x minus 1 as our 2 factors. And that was quite a simple example, so you may have been able to get there straight away. But if you haven't seen it before, it's quite a neat method of factorising any quadratic where the coefficient of x squared isn't 1. If it factorises, that method will work, and then you make it a simple thing in factoring. What we've got is x equals 3 and x equals a third. The big danger is that we walk away from the question at this point, thinking that was quite a relief to get these answers, but it was a simultaneous equations question. It had y in it as well, so we have to go back, think what y was. Y was 10 minus 3x. So now we need to undo our substitution and work out what y is. Y, if x is 3, y would be 10 minus 9, so that would be 1. You don't agree with that. And the other one, if x is a third, we've got y is 10 minus 3 lots of a third, which gives us 9, doesn't it? So a third and 9, and that would be our solution to simultaneous equations. Don't forget to go back and find the other value if you're having to do that. Great. That's stop the video.